Development of multi-purpose agricultural vehicle by using solar power. Abstract. The objective of this paper is to develop multi-purpose agriculture vehicle. India has always been known for its agricultural products and quality, plus it is one of the key drivers of Indian economy. But since most of the farmers are poor and have smaller farms, there is a need to develop a portable agricultural vehicle which is affordable even for the poor farmers. Also, the present agricultural vehicles which are developed have only single functionality, i.e. either only seed sowing or water/fertilizer spraying or only ploughing mechanism. The main components of the vehicle are solar panel, battery, DC motor, centrifugal pump. The function of this agricultural vehicle depends on the amount of solar energy that the solar panel receives, and this solar energy is used to drive the different parts of the vehicle. The crystal-based solar panel is used to charge a rechargeable battery of 12 volts. From the battery, the stored electrical energy is sent to DC motor which is used to drive it. The motor converts electrical energy to mechanical energy, and this energy is used to perform different operations like water spraying, ploughing, seed sowing with the help of switch control mechanism. The power transmission is done by using various gear mechanisms such as simple spur gear and worm and spur gear mechanisms along with chain and sprocket mechanism. This vehicle reduces the human effort in the field of agriculture and finds a solution to increase the mechanization in the fields. This vehicle is mainly useful for small-size farms in order to increase the productivity. This vehicle runs on solar energy which is renewable and is easily available. As mentioned above, it can perform multiple functions like seed sowing, water spraying, ploughing in a cost-effective way. This vehicle makes use of different mechanisms like chain-sprocket mechanism and worm and spur gear mechanisms in order to carry out these operations. Keywords: agriculture vehicle, solar panel, centrifugal pump, DC motor, battery, mechanism. Introduction. India is an agriculture-based country in which 70% of people depends on the outcome of farming. The written history of agriculture in India dates back to the Rig Veda. India ranks second worldwide in farm output. Still, agriculture is demographically the broadest economic sector and plays a significant role in the overall socio-economic fabric of India. In recent years, if we compare production rate or efficiencies of Indian farms to other nations, then we realize India certainly lagging behind. The main reasons for India to lag behind in the development in the field of agriculture are lack of proper mechanization in the farms, smaller size of farms, financially poor. Yadi, Reddy, Department of Mechanical Engineering, Mahatma Gandhi Institute of Technology, Hyderabad, India. Background of many farmers: excess efforts required in performing various processes separately, excess time required for performing individual processes separately, unorganized farmlands in India. Because the consequence of the above-mentioned problems, many farmers cannot afford to purchase heavy agricultural machines, vehicles, due to smaller size of lands and financial constraints. Also, the conventional equipments and methods often require a lot of human effort and multiple operations. Thus, agricultural mechanization is a necessary concept to improve the efficiency and reduce the cost of production. Multifunctional agricultural vehicle deals with the problems faced by farmers, i.e. seed sowing, fertilizer spraying, cultivation and digging. We are looking this project as revolution in small farms in India, which is most uncovered area in this sector, in a cost-effective and more efficient way. These vehicles are capable of working 24 hours a day all year round, in most weather conditions. Moreover, such a system may have less environmental impact if it can reduce over-application of chemicals and high usage of energy, such as diesel and fertilizer, by control that is better matched to stochastic requirements. The inclusion of the solar panels to charge the battery and run the vehicle is also an added advantage by reducing the usage of fossil fuels. The main components of the vehicle are solar panel, battery, DC motor, centrifugal pump. The function of this agricultural vehicle depends on the amount of solar energy that the solar panel receives, and this solar energy is used to drive the different parts of the vehicle. The crystal-based solar panel is used to charge a rechargeable battery of 12 volts. From the battery, the stored electrical energy is sent to DC motor which is used to drive it. The motor converts electrical energy to mechanical energy, and this energy is used to perform different operations like water spraying, ploughing, seed sowing with the help of switch control mechanism. The power transmission is done by using various gear mechanisms such as simple spur gear and worm and spur gear mechanisms along with chain and sprocket mechanism. Our model is designed in such a manner so that it can be run even in small farms and performs the various operations like digging and ploughing, water sprinkling, and seed sowing effectively. 2. Literature review. It is found in the literature that multi-purpose agriculture vehicle is very much useful for small-size farms. Rahul Shukla and Sambit Malik, did a survey on mechanization of agriculture, which examines such predicaments by locating the response of the scientific community engaged in the research and development of agricultural technologies. So, any changes in agrarian structure in the context of output and income need to be taken into account with the adoption of new technologies in the agricultural sector. 1. D.A. Mata and Sunday Mahai have come up with the idea and methodology to develop mechanization in such a way to meet the demands of poor farmers in Nigeria. They emphasized on versatility of the farming equipment for using in different farm operation too. Dr. C.N. Sakal, S.N. Wamer and Rushmi S. Kimote have developed a working model of a multipurpose farm vehicle, which powered by 24 cubic centimeters engine. Their model also does fertilizer spraying and cultivation, digging and seed sowing operation. 3. Professor M.V. Ashutha, Sharath Chandra and Nataraj GK have done design analysis of an agricultural vehicle to optimize the amount of materials used for it. 4. Kashur Sagar Prashant, Kuldip Gotain, have done design analysis to develop an agricultural vehicle by considering various loads acted upon it when various auxiliaries are mounted on it. 5. 3. Methodology. The objective of this paper is to develop a multipurpose agricultural vehicle shown in Figure 1 and Figure 2, which can perform various agricultural operations such as plowing and digging, seed sowing, and water spraying. The vehicle is powered by solar energy, by collecting the energy from the sun and storing it in the battery. Thus, we can reduce the emissions caused by the usage of fossil fuels by utilizing solar energy. The various agricultural operations are controlled by electrical switches, each to drive the vehicle, to run the centrifugal pumps for water supply and to run the seed sowing mechanism. 3.1 Details of the components of vehicle. A. Chain drive mechanism. Sometimes the power is output by simply rotating the chain, which can be used to lift or drag objects. In other situations, a second gear is placed and the power is recovered by attaching shafts or hubs to this gear. By varying the diameter of the input and output gears with respect to each other, the gear ratio can be altered. The agricultural vehicle is driven by a DC motor. Two sprockets are coupled together using a chain drive. The DC motor is coupled to a sprocket which is mounted on the rear axle. Due to the rotation of the motor, the sprockets rotates and rotate the rear axle. The rotation of the rear axle rotates the wheels which drive the vehicle forth. B. Seed sowing unit. The seed sowing unit is made of 3 different parts. The first part is the seed container in which all the seeds are placed. The second part is a shaft upon which 2 spur gear-like wheels is mounted containing a scoop-like structure instead of the teeth. This scoop-like structure ensures that each seed is scooped properly by the wheel and deposited to the deposition point marked by a funnel corresponding to each wheel. The seeds are directed through a pipe attached to the end of the funnel which directs the seeds to the soil at the end of the plowing tool. C. Water supplying unit. A centrifugal pump converts input power to kinetic energy by accelerating liquid in a revolving device and impeller. The most common is the volute pump, where fluid enters the pump through the eye of the impeller which rotates at high speed. The fluid accelerates radially outward from the pump chasing and a vacuum is created at the impeller's eye that continuously draws more fluid into the pump. The water in the supplying unit is impelled out of the tub to the required point of the crops through the rubber tubes provided at the end of the nozzles provided at the outlet of the centrifugal pump. 2 centrifugal pumps are provided at either sides of the supply unit to supply water on the either sides of the vehicle when it is moved across the farms. The amount of water supplied is controlled by control switches which are made connected to the centrifugal pumps and the battery unit. The water supply unit used here is nearly 5 liters capacity which runs on the centrifugal pumps running at 1 2V and a speed of 500 rpm. D. Ploughing mechanism. The ploughing mechanism is mounted near the frontal part of the vehicle such that the seeds can be sowed into the plowed path of the soil. The worm and spur gear mechanism is used to facilitate the movement of the jaws of the plowing tool into the soil. The worm gear is turned using a DC motor which turns the spur gear or the worm wheel such a way that the small axle upon which the plowing tool is mounted is moved up and down. The DC motor coupled to the worm gear is also connected to a switch controller mechanism, powered by the battery. This mechanism is used for power transmission in 2 perpendicular directions. The horizontal rotary motion of the shaft on which the plowing tool is mounted can be converted into the vertical motion of the tool. E. Power supply unit. The power supply unit of this agricultural vehicle consists of a solar panel and a battery. The solar panel used is of 1 2V and provides a power of 10W. The solar panel is directly connected to the battery, charging it when it is left in the sun. The energy which is stored in the battery using the solar panel can be retrieved to run the vehicle and also the other auxiliaries in the absence of sun. To work, photovoltaic cells need to establish an electric field. Much like a magnetic field, which occurs due to opposite poles, an electric field occurs when opposite charges are separated. To get this field, manufacturers dope silicon with other materials, giving each slice of the sandwich a positive or negative electrical charge. In this vehicle the use of charge controller is eliminated as the power required to run the vehicle is low, which in turn decreases the current requirement from the battery. A couple of other components of the cell turn these electrons into usable power. Metal conductive plates on the sides of the cell collect the electrons and transfer them to wires. At that point, the electrons can flow like any other source of electricity. DC motor. An electric DC motor is a machine which converts electric energy into mechanical energy. The working of DC motor is based on the principle that when a current-carrying conductor is placed in a magnetic field, it experiences a mechanical force. The direction of mechanical force is given by Fleming's left-hand rule and its magnitude is given by F equals BIL Newton. There is no basic difference in the construction of a DC generator and a DC motor. In fact, the same DC machine can be used interchangeably as a generator or as a motor. Like generators, DC motors are also classified into shunt wound, series wound, and compound wounded motors are seldom used in ordinary applications because all electric supply companies furnish alternating current. However, for special applications such as in steel mills, mines, and electric trains, it is advantageous to convert alternating current into direct current in order to use DC motors. The reason is that speed/torque characteristics of DC motors are much more superior to that of AC motors. Therefore, it is not surprising to note that for industrial drives, DC motors are as popular as three-phase induction motors. Chassis. The mechanical frame of the vehicle is made of mild steel rods of rectangular tube section. A chassis consists of an internal vehicle frame that supports an artificial object in its construction and use, can also provide protection for some internal parts. An example of a chassis is the underpart of a motor vehicle, consisting of the frame. If the running gear such as wheels and transmission, and sometimes even the driver's seat, are included, then the assembly is described as a rolling chassis. The mechanical frame has the length of 3 feet, width of 2 feet and height of 15 feet. The complete chassis consists of 4 wheels, 2 mounted on each of the front and rear axles. The wheels are driven by the chain drive mechanism where the driving sprocket is rotated by a DC motor. The chassis is also customized in such a way that it can hold both water supplying unit and the seed carrying unit. The water supplying unit is placed at the bottom while the seed supplying unit is placed above it. The battery is placed near the rear axle of the vehicle. The solar panel is placed on the top of the vehicle to facilitate better exposure of the panel to the sun rays. 3.2 Technical Specifications. Title of the project: Development of Multipurpose Agricultural Vehicle Powered by Solar Energy. Solar Panel, 1 No. 12V Photovoltaic Cell, 10W. Battery, 1 No. 12V, Sealed Lead Acid, 7Ah. DC Motor, High Torque, Side Shaft. Wheel Forwarding, 1 No. 12V, 1 Amp, 10 RPM, Internal Shaft dia 8 mm. Torque developed by High Torque DC Motor, 2545 kgf DC Motor. Seating Mechanism, 1 No. 12V, 60 RPM. DC Motor, Worm and Spur Gear Mechanism. Ploughing Mechanism, 1 No. 60 RPM, 12V. Centrifugal Pumps, Spraying, 2 No. 12V, 1500 RPM. Mechanical Frame, 1 No. Length 30 inches, width 15 inches. Chassis Material, 1 in. Square Pipe. Wheels, 4 No. dia. 0.16 in. Total weight capacity of the vehicle, 20 kilograms. Weight of the vehicle, 8 to 10 kilograms. 3.3 Working of prototype model. The agricultural vehicle is used for various purposes like water spraying, seed sowing, plowing and digging. The agricultural vehicle consists of solar panel which receives the energy from the sun directly. The solar panel converts the solar energy into electrical energy by ejecting electrons and hole in the p-n junction by photovoltaic effect of semiconductor material. A lead-acid battery is attached to the solar panel which stores this electrical energy in the form of chemical energy. The lead-acid battery is connected to a switch control mechanism. This is further connected to various other mechanisms like seed sowing, plowing mechanism and the water supply mechanism. In the seed sowing mechanism, the battery is connected to the DC motor which is coupled to a small axle. The DC motor converts the electrical energy from the battery to mechanical energy by the principle of electromagnetic induction. To this axle, Two spur gear-like wheels are attached upon which scoop-like structures are attached at regular intervals on its periphery. The scoop ensures that the seeds will be dropped at required positions in the soil during the running condition. In the ploughing mechanism, the battery is connected to the DC motor. This DC motor is connected to the worm and spur gear mechanism. This mechanism is used for power transmission in two perpendicular directions. The horizontal rotary motion of the shaft on which the ploughing tool is mounted can be converted into the vertical motion of the tool. In the water supply mechanism, the electrical energy from battery is used to run the centrifugal pumps by a switch control mechanism. The centrifugal pump propels the water from the water storage to the required points near the crops. 4. Result: the multi-purpose agriculture vehicle aims to perform various agricultural operations. The developed model runs successfully, performing all the agricultural operations, i.e. ploughing and digging, seed sowing and water sprayer, both simultaneously and individually with the help of electrical switches. Also, the use of solar power to run the vehicle is an added advantage, being a renewable source of energy. Thus, being a multi-utility vehicle, it has other advantages like reduced manpower, increased rate of productivity and better efficiency as it is battery operated. It is cost effective, which is affordable even for the poor farmers. Also, by the use of effective seeding mechanism, the wastage of the seeds is reduced. The electrical switch mechanism makes it much easy to operate for the farmers. The vehicle can also be used for material handling and hence makes it feasible to move heavy loads. Conclusion: the multi-purpose agriculture vehicle aims to perform various operations of the agriculture, which are accomplished by using various components like solar panel, centrifugal pump, DC motor, and motion transmission mechanisms. The various components required for building the multipurpose agricultural equipment has been designed as planned. Multipurpose agricultural vehicle is single system which can perform multi-operations like sowing, water sprayer, ploughing and digging. It can also be used for local transportation purpose for material handling. Multipurpose agricultural vehicle will reduce external charges like fuels, electricity, etc., and this will be helpful for poor farmers. Multipurpose agricultural vehicle is a single system which contains multi-attachments. The equipment weight is around 8 to 10 kilograms, thus it can be carried easily in farmland. The equipment can do the work of 4 labors a day, which reduces the labor cost of the farmer.